Hello everyone, welcome to our presentation. We are Group 1 and this is our Deliverable 2 for Information Management 2. In this video, we'll focus on the transition from second normal form to third normal form in our database design for a Spotify-style music streaming app. We will also explain the functional dependency diagram showing how attributes depend on one another and why normalization is needed to remove redundancy and maintain consistency. So let's begin with the transition into 3NF and see how our tables become fully optimized. But before jumping into that, let's quickly recap what we did with 1NF. As you can see, our normalized table already followed the rules of 1NF. Each row had atomic values, so no changes were needed at this stage. From there, we move into 2NF. This allowed us to align with the business rules and remove any partial dependencies. Now, Charles will now take over.
Previously, after normalization, we have achieved the second normal form. And now we can move on to the third normal form. So, what are the rules of the third normal form? First, the table should already be in the second normal form. Second, all transitive dependencies among non-key attributes must be eliminated. For now, our tables are already in the second normal form, right? But what is a transitive dependency? A transitive dependency is when one or more attributes on the right side depends on a non-key attribute on the left side. Take note that a key attribute, or what we call a candidate key, is an attribute in which it doesn't have repeating values in its rows. A common example would be an ID. Of course, there are no duplicate IDs because if we do, that would cause data redundancy and confusion. So, in our case, we have the genre table.
Okay, so now one of the business rules states that a song can have multiple genres. So we created this table on 2NF so we can clearly see the data needed. Currently, we have a song ID and genre attribute. We have two problems with this. Remember, in 3NF, we must eliminate transitive dependencies. And this table does indeed actually have transitive dependencies. Why? Well, firstly, song ID is a foreign key that originates from the song table. Another thing is it has repeating values in its rows, so it cannot be a candidate key. Our genre table does not actually have a candidate key. To solve this, we will create a surrogate key for our genre table. Now, a surrogate key is a synthetic key which will act as a key for our table. So we'll have to replace our attribute song ID into our new candidate key genre ID. This way we satisfy all the rules of 3NF and this table is now on third normalized form.
However, we have another problem. Because we remove song ID from the table, how are we going to identify which song has these genres? If we leave it as it is, then now we fail to follow our business rules. But we have a solution. We will have to create a junction table. A junction table is a table that connects two different tables that doesn't directly connect because they don't possess any attribute that could link them, also known as a foreign key. But how are we going to do that? Our goal is to identify which song has what genres. So all we need to do is to add song ID from the song table and genre ID from the genre table. Now, they're connected, and by simply tracking the song ID, we can identify what song is it and we can also see its genres. Now then, we can proceed to other tables. And we can see that playlist table also have a transitive dependency. Playlist create date relies on no primary key. User ID is a foreign key while playlist name could have a duplicate value. So, we would need to create a surrogate key that we will be calling as playlist ID. After this, the playlist table now have a primary key eliminating transitive dependency. And for now, that's all the tables that don't follow 3NF rules. All the other tables are already in third normalization form, so we don't require fixing, and we can show them as is.
In 3NF, we removed transitive dependencies. To do this, surrogate keys like genre ID and playlist ID were created as a primary key. Then a junction table was added to properly connect songs and genres. With these changes, all tables are now in third normal form. Now that you've seen how tables were normalized, let's move on to the functional dependency diagram. A functional dependency shows the relationship between attributes in a table, specifically how one attribute can uniquely determine another. By using this diagram, we can clearly identify which attributes depend on the primary key and also spot any transitive dependencies that need to be removed. This will help us understand why the transition from 2NF to 3NF is necessary to our Spotify-style music streaming app. Now, Jeff will now discuss the functional dependency diagram in 1NF.
The primary key of this table is a combination of three attributes: user ID, playlist name, and song ID. This means each row is unique because it shows which user has a playlist and which song is inside it. Next are the partial dependencies. From user ID, we can get the username and email. From user ID and playlist name, we can know the playlist created date. From song ID, we can find the song title, duration, album ID, artist ID, and genre. And from the pair user ID and song ID, we can know if the user liked the song or not. With that, I'll pass it on to Charles to explain the transitive dependencies.
Now, let's move on to the transitive dependencies. Album ID gives us album name and artist ID gives us artist name. These are transitive dependencies because they depend on a non-key attribute, not directly on the primary key. Finally, I did not use playlist ID or stream date as determinants because they are not part of the real dependencies in this table. In short, this diagram shows the correct functional dependencies divided into partial and transitive based on the chosen primary key.
What you see here is a functional dependency diagram in second normal form, or 2NF. This diagram represents how our music streaming database is structured after normalization. On the left, we start with the user table, where user ID serves as the surrogate key that determines the user's username and email. Then, we have the playlist table, where playlist name acts as the primary key and is linked with playlist created date and the foreign key user ID. Here, we also note a transitive dependency since playlist created date determines playlist name and user ID.
So next is the song table, where song ID is the primary key that uniquely determines the song title, duration, album ID, and artist ID. In this table, we see the another transitive dependency, since song ID also determines the genre. The album table follows with album ID as the primary key determining the album name. On the right, we see the artist table, where artist ID serves as the primary key that determines the artist name. Finally, the streaming activity table uses a composite key made up of user ID, song ID, and stream date, and this determines whether a song was liked or not.
In summary, our transition from 2NF to 3NF removed all transitive dependencies, ensuring that every attribute depends only on the primary key. By adding surrogate keys and introducing a junction table, the database is now more consistent, efficient, and aligned with the business rules. The functional dependency diagram also makes this relationship clear, giving us a solid foundation for the design. That wraps up our deliverable 2. Thank you for watching and see you in the next deliverable. Thank you.